Hi Math 113. I am going to do a video for what we did this week, and I'm going to kind of squish the 2 days together. So if you missed either day, if you missed Monday, it'll be at the beginning of the video or the first couple installments of it. And then if you missed just Wednesday, you might have to kind of just watch to see where that starts. But in general, this week we've been talking about division. Okay, so we are going to talk about a definition of division. A divided by B, okay, and B can't be 0. And we'll talk about that more in a few minutes, right? But we can't have whatever we're dividing by be 0. So in this way of thinking about it, A is going to be the number of items to be divided. And B could be one of two things. It could be either the number of groups that will be formed, or it could be the number of items in each group. Okay, so let's say I have 12 items. And I want to divide this. So I want to have 12 divided by 3. So 12 is my number of items. I can see that here. Now, there are two different things that the 3 could represent. The first thing is that it could represent the number of groups. So I want to take my 12 objects and I want to divide those into 3 even groups. So the way I've written it in this array, obviously it's a little bit easy to do. So I could say, okay, here's 1 group, here's 2 groups, here are 3 groups. I've done that evenly. Now if I do that, then my answer is going to be the number of items in each group. Okay, so we know there are 12 items. We divide them into 3 groups. That means there are 4 items in each group. Okay, well, what if instead I think about it the other way? What if I think about this as, instead of the number of groups, the number of items in each group? So I want, instead of having 3 groups, I want to have groups where there are 3 items in each group. So there's 1 group, there's another group, there's another group, and there's another group. Well, now my answer is 4. Well, that tells me not how many are in each group. There are 3 in each group. This tells me now the number of groups. Okay, so it's all the same numbers. It's just the representation of what you talk about there. So, for example, you could say, okay, I have, 28 pencils here. So if I want to give each child 4 pencils, then how many kids could I give that to? So I know there are 4 pencils in each group. How many groups of 4 pencils can I make? Or you could say, I want to give these to 4 kids. That's how many groups there are. How many pencils can I give to each of those 4 children? So it goes back and forth that way. All right. Let's see. So, I'm trying to think next. Okay. So, we also can think about how this is related to multiplication. So if I have 12 divided by 3 equals some number, well, we can start out, especially with division, by thinking about that this means 3 times some number equals 12, or some number times 3 equals 12. So remember before we talked about A times B being this many groups times this many items in each group. So kind of depending on where you're calling this, you can put the 3 and the unknown in either spot, but we know that's okay from the commutative property. All right, and let's go back for a minute to this statement that B cannot be 0. So let's pretend that we have 2 divided by 0. And we want to know, I'm just going to put a question mark, we want to know what that is. Well, if we think about this by flipping it into a multiplication problem, then that's going to help this become a little bit more clear. So 2 divided by 0 is some unknown number. Well, what if I flip it around to a multiplication problem? One way to write this is that 0 times some unknown number has to equal 2. So think about that for a minute. Okay, what would I multiply 0 by to get 2? 0 times what equals 2? Well, if you think it through, that can't be possible, because 0 times anything always equals 0. I can never multiply 0 by something and get 2. So this is one representation of why we cannot divide by 0. Okay, on the other hand, can we divide 0 by some number? So could I have 0 divided by 2? Well, we can. Okay, and let's see why. Now I'm saying 2 times some unknown number equals 0. Well, what do I have to multiply 2 by to equal 0? Think about this, right? This would be 0. So I can make this statement. I can't make this statement. And if we're thinking about groups, I mean, the word problems end up sounding a little bit strange, but they make sense. If I have 0 pencils and I want to give them to 2 of my friends, how many do each of them get? They get 0. So it does make sense. All right, so we've talked about the definition. We've talked about the 2 ways to think about B. We've talked about going back and forth between multiplication and division. And we have talked about division by 0 or 0 dividing by a number. So we're just going to talk for a few minutes about fractions. Okay, so let's say we have 29 pizzas, and I want to divide those evenly among 6 classes. Okay, maybe 6 classes in the school read the most number of books last month, and they're going to get pizza, and we've had 29 pizzas donated. So I want to divide those. So if I did that, so if I have my 29 pizzas, and I want to divide them into some classes, and we can do this even with students that haven't learned formal division yet, but let's say we have a box to represent each of our 6 classes. Okay, and I can go through and put 1 pizza in each class one at a time so that I distribute them evenly. And again, with small kids, right, you could have little pizzas. You could do something interactive where they're each taking and putting them up here. We're getting the idea that we're dividing things into even groups. So we could put pizzas. So there are 6 pizzas, 7, 8, 9, 10, 11, 12, right? We keep doing this. So this would be, I've used 18 of my pizzas now. 24 of my pizzas. Okay, so I'm at 24. If I try to go back and do this, and again, this would be great to do with some kind of interactive magnetic board or something. If I put another one in, so I'm at 24, 25, 26, 27, 28, 29. So I can't do that because it's not even. 5 of the groups would have 5 pizzas, and one of the groups would still only have 4 pizzas. So they each have 4 pizzas right now. I have 5 pizzas left, so I'm going to draw my 5 pizzas up here that are left over. So there are a couple things we could do here. We could say, okay, well 29, if I'm dividing it into 6, each group got 4, and there was a remainder of 5. So in this case, 6 is my groups, right? I have 6 groups. I have 4 in each group, and then I have 5 left over, okay? I could leave it like that. I could take the 5 extra pizzas and go distribute them to, the principal or the PE teacher, whoever else in the school. Or I could try to split these up. So we know that not each class does not get a full pizza. But the easiest thing to do is to say, okay, let's take this pizza and split it into 5 or 6 equal pieces. So each of these classes, okay, so I'm going to label the classes 1 through 6. Each of these classes gets 1 slice from that pizza. And then I've used up that whole pizza evenly. Then let's do it with this one. So each of the classes gets 1 even slice from this pizza. So far, they still are all being even, right? Because let's have dots be slices. Now they each have 2 slices of pizza. They have 4 full pizzas and 2 slices. And we're going to do the same thing for all of these pizzas. So each class then gets 1 slice from each of those pizzas. They don't get a whole pizza because a whole pizza would have meant we had 6 to begin with and we only had 5. So let's look at class 1, for example. They get this one right here, and this one, and this one, and this one, and this one. They get 5 slices. Each slice is 1/6 of a pizza. So they get 5 times 1/6, right? They get 5/6 of another pizza. So how much pizza does each class get? Well, they got 4 pizzas, and then they got 5/6 of another one. That's what's going on here as well. We could say 4 and 5/6. Okay, we're dividing everything into 6 pieces. It just so happens I don't have enough to make 6/6, another whole, but I have part of that. I have 5/6. Now, it depends on the context whether you can do either one of these, okay? Let's say I have 29 students and I want to split them into 6 groups. Then I can have 4 in each group, and then there are 5 students left over. And I have to decide, am I going to make a different group? Am I not going to use them for this activity? But I certainly can't put 4 and 5/6 people in each group, right? It doesn't make sense with the context. So it kind of depends on the context whether you can, have something left over, whether you can have a fraction, how that's going to work. All right, so kind of overall the way we can write that is if we have A divided by B, it's going to equal the quotient, that's the name of the answer, plus the remainder. Or we could write it as the quotient with the remainder over this number that's the divisor. So 4 and 5/6. Okay, I'm going to stop for here. That's really what we did on Monday. And then I will do another video to recap Wednesday's class.